thanks, Tom, and obviously thanks to everybody who's got me today. I have to say, I hold my head when I get introductions like that. I think I just try to get on and do my work. And that is the case. As Tom introduced, an independent artist. I live very simply in Suffolk. I've been very lucky with my career, but then you make your own luck. I appreciate that. On the screen, running during this interval, is, I think, a fair representation I can throw. I have, for many years, supported a young family, along with my wife, as an income, producing domestic ware pottery. I know what functional pottery is, and the selling of that, the marketing and all that. But my interests were always much more sculptural. And they are stimulated by, on the right-hand side, that relationship between us humans and then the nature out there. And ultimately, it's the nature within us. And then in the middle is something that has developed over the last 17, 18 years. And that is an interest in the use of computation to drive this tool set that I now use. So that's my kind of introduction. There's a narrative to the story that helps me kind of get through the nervousness of presenting something that I've presented many times. I was born in South Africa. Most of this work, all this work is Zulu. But at a young age, obviously, that is absolutely central to the forming of, kind of one's worldview. Two things here. Obviously, one is the kind of the cultural difference that I was colonial white. My parents came from Britain in an apartheid South Africa. So absolutely molding my attitude to art making is an embarrassment by the sort of colonial imperialism of European culture. I was studying in a white university in South Africa. I was studying European art. Your choices were to be a painter or a sculptor. This was the indigenous work that I saw alongside me. It was apartheid South Africa, obviously. Most of this would be classified as craft work within the canons of contemporary Western art. And unfortunately, this is my understanding in Britain, slightly lower than a fine art. Now, culturally, you just cannot start making those differentiations. This is the creative work of that culture. And this is, really, I'm kind of slowing down and making that point because I think we need to be very, very aware of cultural difference and how culture is inevitably a human construct and a respect for different cultures. And what this has done for me is that I was always a more three-dimensional person. Sculpting was possibly the obvious route for me to take within art school. But I was interested in material and pottery and all that kind of stuff as well. But I chose to be a potter in that pottery is a media or medium that is absolutely universal. So you'll see as we go on, I talk about the language of pots. And it's, as a potter, in my first slide, I'm an artist and a potter I'm very comfortable with. The other point, more in context with this talk, is the materiality and the systems used in the making of these pieces. So top right is some basket pieces. Now those are for brewing beer. So when they swell, they are actually waterproof. They obviously sweat, and that helps keep the beer warm. But if you think about the structure of those pieces, they are actually coil built. So grass is taken, and it's slowly coiled from the base, very similar to the pots top left. So actually in the process of making there's a similarity between those two. But then each layer is stitched. So that system is set up. And you can kind of see the computation that's going on there, isn't it? So the patterning on that is coming out of the process. Bottom right, beaded work, and these are skirts. The skirt for an unmarried woman is different to a skirt to a married woman. So these are not just not decorative objects. Obviously, they have a cultural heritage to them. But if you kind of deconstruct that a bit, those are pixels. So there's not a big leap between the sort of the system thinking that is going on there and that is inherited within that culture to the ways possibly we're working with computation now. This was the other big influence for me out there. Yes, that is me. It's aged 8 or something. My father was working for the Wildlife Preservation Board out there trying to do, an operation called Save the Rhino. That rhino is not dead. It's been immobilized to then be transported to try and save the white rhino that was endangered then and set up new breeding communities, whatever rhinos have anyway. The result of this being in that African wildlife is I end up with a worldview, not surprising, that is one of evolution, ecology, and then the other thing is experience. Ecology, I think, is always interesting. That obviously it links in with the whole evolutionary thing. But we tend to think of ecology as out there. Again, it's something how nature mixes up between each other. But you actually just think about the ecology of your own lifestyle and the ecology of your practice. That if you make a bit of a gap in your practice, how is that going to get filled up? All right? So ecology can be like, cutting down the rainforest and then what grows in its place and what's been lost and so on and so forth. I think you can think about that in your own practice. You take something away from your practice and what's going to start filling that practice. So the whole time I'm humanizing that. And that point then of experience is you don't know how hot it was on that day in South Africa. You don't know what the smell of that animal is. And I kind of specify that because you'll see I've worked in virtual reality for a period, and that's in a really interesting area, but I always come back to the physicality, the materiality of it all. So I'm kind of trying to explain probably why I got into using computation in pottery. That is the pottery world, particularly in the UK, that is quite conservative within ceramics. I work mainly outside of Britain, to put it in another way. Obviously, these are embryos. Along the top is, it gets read vertically. I'm sure you can read it. And what the animals are down the bottom. There's a different time span as it comes down. But this is a form of coding and materialization, isn't it? So here you have a genetic code that forms very similar embryos, but that code is different and you get a different form coming out the end of it. And that has always absolutely intrigued me and is what has informed the way I try and work. Photograph of soap bubbles, that minimum surface. Again, how aesthetically, I really like these things. I think they're beautiful. I'm guessing you probably do. Now, what's going on there? That there's a communal awareness of the beauty of this curve. Often I'm giving this talk more to ceramic people, and you say if you're working on the pottery wheel, what is a really beautiful curve? And it's not surprising that it won't be something like this that is a natural curve. And so our eye has evolved to actually appreciate that. So an appreciation of the nature out there has obviously evolved into the wilderness that is inside us. I lived in the African wilderness, but I've come to realize now living in Europe that wilderness is inside myself. So that's my background. I, kind of rather stirring the pot, but I always say I'm a traditionalist, and I am. I have, come from that studio pottery background, and tradition is a continuum. Where's it going to go? For me, it's important to make work that is a reflection of the time that I'm living in, and the tool set that we can now use includes computation. I mean, we use it in every other field. Why shouldn't we be using it in our apparent craft work or in artistic practice? So, as Tom introduced earlier on, I make my own equipment. And there's a point there that, I've had an interesting week with Tom that we've been, Tom builds machines here. I work in Suffolk. We communicate anyway. But he picked up on something during a workshop yesterday. He said, "Oh, you refer to it as an instrument." And again, I'm picking my terms quite carefully there, is that so often the robot arm or the robot there is a machine, it's a tool that's been used out there. I build these things, I understand them, I code what gets put into them. I'm really interested in music, and this, how you don't refer to a piano or a wind instrument as a machine. Somehow, when does a machine become an instrument? I'll talk about this work going forward, but you can see, gas kiln for the ceramic people, gas kiln in the back that I happen to make myself, but and then some electric kilns as well. So, I absolutely hold my hands up. I do enjoy all the techie stuff, but it's a combination of using the material, using the process, and whatever content you want to express within the work, and using their technology to do it. So this is 1999, as you can see up the top. This is the first time I started using computation. And one has to chuckle a little bit that 10 artists within the UK were commissioned to produce a CD-ROM about their artistic practice. So the library service thought that the way to view this new multimedia content would be in a CD-ROM sitting in a computer in a library. So, the historical line, this is pre-internet. Now, obviously, this would just be an internet project. Younger people, you probably don't get it. You don't know what a CD is. I mean, it was even before DVDs, sort of thing. But again, it puts it in context. We're now 3D printing. This was, 18 years ago. Where's it going to be in another 18 years? I'm sure I don't need to tell you all that. But there are 4 screen grabs, from the CD-ROM in here. All this is computer generated. It was the first time that I sort of started using 3D modeling programs and computers. My interest was there, but it was absolutely kind of cemented with this. Bottom left, and this is, for 6 months I worked in virtual reality, making virtual pots, whatever they are. But bottom left here is I offered the viewer a teaspoon that you could pick up with your mouse, and then you could go over and clink all the different ceramic pieces that are there. Now, you can't walk into a real exhibition and pick up a teaspoon and start wandering around and hearing what the different sound is for something that is more earthenware or something that is more porcelain. So I thought there was, a really interesting point here in using multimedia. You could give a heightened experience to your viewer, but it was a different sort of experience too. I was very pleased to get back into the reality of my studio and actually get back to the physicality of the material. Part of, let's get these going as well. Part of the brief of this CD-ROM was not only to produce an artwork for the public to appreciate, but was also to explore multimedia. And it was the first time I really started using symmetries a lot. Possibly a bit dumb for someone who had worked on the pottery wheel, and that is spinning a mirror symmetry all the time. But it took me into areas actually looking more at evolutionary psychology and possibly why symmetries are important within aesthetics. And so a bit like I was talking about a curve, I'm now talking about symmetries. So at one level, they're very, very kind of objective systems that one might use or look at or consider for design. But I'm interested in then how our human sensibility reacts to that. So it's what the viewer brings to it in a very subjective way. At one level it's objective, but I'm now talking about the subjectiveness of that. So I'm now just showing you, in a way, the outcome of that. I said I was really pleased to get back into physicality of the studio, but I kind of, having worked in virtual reality, quickly learned some things, and one was about scale. On screen, you can just zoom in and out. So I started making pieces that are called handheld pots. So the scale was very much to your body. Once again, I'm sure speaking to architects, I don't need to speak to, be emphasizing this. But it's that subject value of you've got to remember who your viewer is and what their experience, their bodily experience of the object is going to be that you're dealing with. A laptop, so the next sort of scale I worked was sort of size of someone's head, what might be rested on on someone's lap. That's obviously one piece from many different angles, so that kind of three-dimensionality has always been important to me, but again, working in 3D modeling programs, it became all the more. These pieces are made out of a number of thrown elements. I would throw pieces and then start collaging them together. So the digital aspect of this stage was only, and it wasn't necessarily in the design, it was just in the conception of them, but the pieces were sort of analog in a traditional manner. And then large-scale floor pieces, and again, that physicality of the maternal pot lying on the floor is very much the size of something that you might actually sort of lie down in, relate to quite closely. The other thing, having worked in virtual reality, was a lack of orientation in a way. Because there was no gravity, things just sort of had a weightlessness and what was top and bottom. And it was a realization that working in physical materials, they have a weight to them. And so they have to be structurally, when you're building, most ceramic vessels are quite base heavy because it's quite a heavy material and it has to support itself as it's building up. And I rather liked the effect of how working in virtual reality, you didn't have to put a base, obviously, for one, and it could just very easily spin in that sort of weird space. So you can see I was then very much concentrating on making sure that pieces just sort of floated or sat on the floor to the extent of actually suspending pieces. And again, that was then suspended at eye level so that the viewer actually had a different reaction to, a confrontation to it than, say, a piece sitting on the floor. A continuation out of that was a residency in Denmark, and the proposal for this was that I'm dyslexic. During my schooling, I wasn't aware of that in the 60s and 70s. In South Africa, dyslexia wasn't a word that I'd ever heard of. Unfortunately, it's not uncommon to pass this on to your children, and my one daughter is dyslexic, and it was picked up at her junior school, and then when it was picked up on my daughter, I realized, well, that's what I've got. So my daughter and I were doing dyslexic programs together, and one of them was a typing program to help with spelling. And so coming up on screen, you've got words, and then you start typing the word on the screen. Now, as a school kid, part of dyslexia, and I'm guessing it could well be 50% of this room are dyslexic. In art schools, certainly in the UK, much higher in 3D or three-dimensional courses than in other academic courses, but anyway. As a scholar, I just could not do my spelling. It's a matter of memory recall. I'm afraid names are similar. I'm not going to remember. I should try and remember names, but it just doesn't come back to mind. With a spelling program, it was on screen. You started to find that your fingers were actually going to the keys. And so you were starting to spell at the tips of your fingers. It was a kind of motorized haptic experience that you started to remember with, do the spelling with. That opens up the kind of intelligences, this is obviously getting into now educational theory, but there are, depending who you're going by, up to 5 different kinds of intelligences. And so often one tends to only think of kind of reading intelligence or numeric intelligence. But there's obviously that haptic experience that often sports people have much more of. And not surprising, architects, 3D thinkers have a different kind of spatial intelligence. And so in this project or this residency, it was about using the 3D modeling program to attune my eye to new shapes. In ceramic, we tend to either make coil building or throwing. On computer, you can make literally any shape. The process changed it so the visual language can change. And that's what I was wanting to do here. And these were pieces that came out of that period of work. So I started to get more and more stuff in my computer, modeled in 3D programs. And the logic was to get it out of my laptop, mainframe, whatever, into physical object directly as a 3D printed article. And 2007, I went to a symposium around use of digital techniques in ceramics, I was starting to see the early plastic printing pieces. But anyway, I was advised that this guy, Adrian Bauer at Bath University in the UK, was developing, bottom right, a DIY printer. So I actually wrote to him and I said, you know, what's the chance of adapting one of these to print in ceramic? And he said, well, you know, there's a possibility, but one, you're probably going to need to be a computer engineer and need coding. And I said, well, I'm neither of those, but thanks a lot. But we theorized it would probably be about extruding clay out of syringes in some way or other. Now also, I have to add to this, you've got to remember 2007 was pre the financial crash. It was more 07, 08. And the whole sort of maker movement and fab labs came almost out of that crash. So this is pre that period. This is now pre, you know, the interest in DIY, 3D printing, and so on and so forth. But anyway, from his comments, I thought, well, if I'm not going to actually get into coding, that is where my kind of interest lay more than possibly just modeling in a 3D program, I need to get on with it. And so I found processing that is a Java-based format, and I've since taught myself this. So, I mean, you know, all the techniques and the skills that are here are things that I've taught myself mainly off YouTube. So with the coding, some of the first pieces, well, I managed to get myself a drawing residency, and that drawing residency was about using the code. So this piece of code is a matter of take a pixel, allow it to wander off across the page. After a random distance, it dies, it returns to the body, and then starts again. I then mirror that left and right, and then once I say to you that these are my bug drawings, you can't see them as anything else but bug drawings. And this gets back to that objective-subjective thing, that at one level, these are just objective random drawings, but because of our psychological makeup, we read them as bugs. Well, that's my reading of it. So I really like that level of where the work, I hope I'm not a kind of very egotistical artist. It's more about making the work and putting it out there and leaving space for the viewer to actually finish the work. And I think then using computation, you can get into this area so much better. So alongside the drawing, I was then starting to experiment with extruding clay out of a syringe. So these are made with a small syringe, and a matter of understanding how the material will extrude from the syringe. So, interesting here, although on the right it might look like something 3D printed, it's analog on the right-hand side and computer generated on the left-hand side. So there's a number of these wormholes. It's the idea of it's the space actually below the ground level that has been sort of brought out. But I'd like to think, that sort of visual language of having used computer 3D modeling was coming out, into these ceramic forms more than traditional ceramic pottery forms. I got quite carried away with those. So alongside working on that small little scale, I was working on these that are about 1 meter tall, same process, coil built, and I always sort of flag this up in that once I got onto this 3D printing, it sort of has come along quite quickly, but it's because I have the tacit knowledge of how to produce a piece like this. So something like this takes sort of 10 days to make, because you can only work on about 10 centimeters, and then you've got to leave it for a day to get stiff, and then you do the next layer, and then you do the next layer. So the bottom of a piece like this is near bone dry by the time you get to the top. So the actual process and the material of making it are a kind of knowledge that I fully understand. So I kept watching the internet in hopes of finding the ceramic 3D printer, and then sort of one day it popped up. So, around 2010, this appeared on Google, on searches anyway. And in the blue shirt is Dres, and over on the far side is Claire, who make up Unfold, that is a design group in Antwerp. So anyone who's following ceramic 3D printing, these are the couple who first really cracked it. So anyway, I contacted them. I'm not far across the channel from them, and went and visited, and we've set up a friendship since then. But basically, I copied their system to begin with. So this kit here, that is, you can see, was almost that Adrian Bauer kit. We would buy as a flat pack and put it together, and literally use syringes filled with clay that were pressurized with a compressor, and it was, or is, computer-guided coil building. So these are the sort of pieces I was producing then. We had a small build volume, so porcelain was an ideal material. For me, it was important that just because it was made with all this technology and new and everything else, you still wanted the beauty of the porcelain to show through. The glaze quality, all of those things. I'm still playing with the orientation I was talking about. So these actually printed on their rim and then turned over later on. And then also making use of some of the processes going on. You can see the early slicer wouldn't do a spiral. It always rose in the same place. So you ended up with that heavier sort of scar. Oh, sorry, I don't mean that. Well, I'll go on. Come on.
Escape.
Thank you. That previous piece had been modeled in a 3D modeling program. This is now getting onto using the coding. So in a piece like this, I can code just a single piece of code and then I change the numbers, or I build sliders into that, and I can change the sliders. So it's using sine cosine to get the wave quality. I can then capture, build the mesh in the code, capture that, change the numbers, rerun the code, and capture it, and capture it, and capture it, capture it. So that sort of idea of a stone going into the water and the ripple going out all comes from one piece of code. The sizing I would actually do later on in my editing, my 3D editing package. All the software I use is open source, so I use something called Blender. Now a clever coder, and this is I guess the point I'm trying to make, a clever coder I'm sure would change the sizes as well. But I don't consider myself a clever coder, and I don't necessarily want to be a clever coder. I just want to be able to use code and know enough about coding to generate work out of it. So kind of a similar morphology of just changing the sliders. So I've set up this video left and right. On the left is the coding going on, and then the physical output on the right. So the computation and the materialization, it's all, again, hugely speeded up, but I would have generated and processing, then I do my editing over here in the Blender package, and then on the right-hand side, this is a good 5 years ago, is printing it off on the old Rapman printer. In the right-hand side, you can periodically see an orange thing. That is a hairdryer that I'm using to stiffen up the clay as it went. Oops, let's just stop this. This next section is the sound pieces that I do. So on the left-hand side here, this is actually Spotify that is open. I can embed the sound into the code as well. But on the left, I'm thinking like a traditional potter. I take a pixel and I slowly coil it as though I'm doing a coil-built pot. Then the volume and the rhythm of the sound, that is a digital capture, is added to the radius of that spiral as it happens. So whereas you would get a sound quality, going a flat graph, I've now bent that around. So it is slowly, in time, building up. And again, on the right-hand side, it's been printed. So on the right-hand side, I'm now using a different printer. So within this sequence, it's over a period of years that I've slowly kind of moved on in the printers. A real problem with working in clay is obviously it's this soft material. It wants to fall down, and support is, something that needs to be sorted out. So I adapted my original Cartesian square printer to take a little box, and there the print disappears down into the box, and I'm offering up powdered clay, the same clay as the object is made from. And that enables me to do the much more rounder forms. So on the left here is actually now random forms to being generated, so that's similar to the bugs. And on the right-hand side, the lights there were not necessary for photographic reasons, but to actually set the pieces stiff while I'm printing. So I'm using heat lamps to set it as well. Now on the right-hand side, I'm now using the WASP printer that is also a Delta printer, and we're back to the beginning again. So this is a sound series piece, Benjamin Britten's Four Seasons. I live in the same landscape where the British composer Benjamin Britten did when he was composing this opera. So I've taken those four interludes and put them onto the four vase forms. If I ran the vase in silence, they'd all be the same size and the same shape. So the differentiation you're getting there is the difference in the quality of the sound, and the slight difference in the height is the difference in the interlude. Although I said, it's about the landscape, we live in the same landscape, or now do, we're on the edge of the English Channel, and ultimately that's probably a seascape that's on those pieces as much as a landscape. In these pieces, on the left is the song thrush, on the right is a piece of Bach music. I'm interested to know whether there's actually a visual correlation between human music and then the animal sounds. This project needs a lot more work on it. I actually need really to collaborate with somebody who understands, the structure of sound so much more. Random growth forms, I alluded to them just now. What's going on here is using something called toxic libs for anyone who's working in process. Carsten Smith's library. It allows me to work with voxels, and a virtual sphere is then coded and allowed to wander in a defined space in virtual space, in the virtual computer. And what intrigues me here, and if I go on to the next one, these are, like the bug drawings, randomly grown, but if you're seeing figures in these pieces, it's because we try and make sense of the world in our own image. The iceberg series, these are then unglazed. All the previous pieces have been glazed porcelain. These I actually leave unglazed. And they are generated out of Perlin noise. And anyone who knows Perlin noise, it's a mathematical function. It is also used to generate landscapes in computer graphics. But it's a form of randomness, but the randomness is always knows what random has come just before that. And what really intrigues me here is that the content of this work, the icebergs I'm talking about kind of are dealing with our environment and potential global warming and so on and so forth. But that Perlin noise is giving me the same surface as the surface of degrading ice or melting ice, or in Earth, possibly Earth that's eroding Earth. The material I'm using is porcelain. That is obviously very hard in contrast, but I'm using it to talk about the translucency of it. So that's the material, and then the process, it's been layered in the 3D printer, layered down in the same way that ice is laid down in an iceberg. So, within these pieces, my material, my process, and the computation come together, I hope, to express the content of the work that I want to talk about. There's a whole tree series as well. I won't go into that too much. These harmonic vases, there's, again, I kind of look at these mathematical functions that are kind of interest. and often have implications within astronomy or some science, and then put that onto, in this case, is cylinders. And I'm really intrigued. I really like Brancusi's work, is that there's, I think, a similarity between these and, say, Brancusi, and not surprising, Brancusi was looking at very traditional work. So there's, kind of a completion of that the coding that I'm using, I'm interested in the way it imitates nature, and nature's a representation of tradition, and so on and so forth. So my seedbed piece, again, it's one small bit of coded app, relatively small to how coding can be. And then I set it up with sliders, and there are about 8 parameters to this, and I change the parameters. So we start top left, and you can see I've, as such, evolved the shape going across on the right. I've evolved the shape coming down on the left here, and so inevitably on the diagonal you get that generation and the complexity that's happening down the bottom. So at one level it is just that sort of formal experiment, but then at another level I can say, consider this as an idea, and you can start to understand how ideas, or visualize how ideas kind of generate and spread, and how it can become complex. Or you could take it as your own life, thinking that is, your early childhood and the experiences that you pick up through your life. And so it's not surprising that you develop into the person you are towards the end. It's the piece on show. What is interesting here is, as I say, I tend not to get invited a lot into ceramic shows, particularly in the UK. I mustn't go too hard on that one. But this I was invited to Ars Electronica. That's a digital festival out in Austria. And they were delighted to actually have some physical objects rather than screen-based stuff. So it's, it's just a bit of a turnabout that you're a bit shunned by your own community, but accepted by other communities. This series, I was invited to participate in the Chinese Ceramic Biennale. So I have a friend who's studying ants in Nottingham, and so have become interested in swarm behaviors through him, and emergent design properties or emergent properties. So these pieces, they're about 50 centimeter high. The coloration is, I'm using different colored clays as it gets stratified up. The texture on these, admittedly, is using the Perlin noise. But the Nottingham friend, he's studying as an engineer, as an architectural engineer, is studying ants and the structure of ant hills. So that emergent property there is how, without any one designer, is an anthill being built such that where the queen ant and the garden where they grow their food is kept at a constant temperature in an Indian climate or in a South American or an African climate. And they're looking as to how these structures can get built by the ants such that they are ventilated so that ventilation all works properly. And their current sort of theory is that the ant randomly goes off and gets a little bit of clay, earth, and puts it on the very edge of the tower that's slowly been, the anthill that's been built up. The heat is rising out of the ant nest, passing over that edge. Other ants will actually either go off and get some more, or as they're going, they test the edge. And if the edge is still soft, in other words, their instinct is, if the lump of deposited clay is soft, they will pick it up and they'll go and move it somewhere else. So that emergent design is such that clay that is in the correct place has been stiffened up, and clay that isn't in the correct place remains a little bit softer and gets moved into the correct place. And as a maker, I think that's really, really interesting. And as somebody who's kind of interested in coding and systems, all the more particularly interested. So the previous series were one ant series, and then these Langton ants, Mr. Langton, who was a theoretician working around game theory and chance, so these were my outputs. This is his Wikipedia page for that, has this mind game, that you can populate the checkerboard, and then you put your ant on there, your virtual ant, and if it's black, it turns right, the ant does, and then moves forward onto the next square, and the square turns to white, and if it's white, it turns left. And what's really interesting here is you get a chaotic pattern happening on the right hand there, but after a period of time, after the generation of that, it then starts getting into a loop, and it gets itself into a tied loop. And it's a matter of seeing kind of in very simple chance experiments is what emerges out of that. So what I did was to get the bit of coding from this normal two-dimensional visualization and coded it up into 3 dimensions. So if the ant goes back over a square, that then grows in height. And I was just really intrigued, and it was kind of a beautiful completion to it, that something that is called Langton's ant actually grew anthills out of it. So in the visualization that's happening on the right, you can see the ant literally wandering around, and then when it goes back over a square, it gets slightly taller. I think in this bit of movie, I am pressing S for anyway, so that, I guess, shows you a representation of how I work. I can then capture an STL file and a little JPEG just to remind myself of what the actual visualization looked like. And so that was what the final display looked like. So I've got my Langton ants, my big ant hills, and then the ant drawings that went with it as well. I referenced the curves earlier on, so, you know, kind of wouldn't life be really uninteresting if everything was a straight line, you know, that we have these curves. So again, at a very formal level, that play of the curve, but at another level, you know, obviously where I'm working, I'm, you know, interested in that area of art and science and art and nature, is how important curves are in everyday life for whatever reason. I flagged these up a little bit because in the slicing of 3D prints, slicers are getting more and more sophisticated, but very often the slicer, the piece of software, doesn't like the idea of a path going back over itself. So these pieces are generated in code, as I said, and I code it straight from the processing code onto a text file, and that text file goes straight to the printer. So, you know, in those pieces, I'm starting to think more like a printer is, right? Actually, how can I just guide the print nozzle into the correct place rather than going through, you know, making a shape and then slicing that up and then passing it over? So it's some big random growth pieces drying in the studio. Tom in the introduction spoke about this machine tool. We had those, Unfold, myself and others were starting to use those little Cartesian ones. 3D Systems, big business, bought out the little startup company that was doing those kits. And sort of, so all of a sudden, you know, kind of all that knowledge that we had built up was taken away from us because we didn't have the kit. And I thought, I just don't want to be in that position again. And I felt, so this was, what, as we say, 2012 into 13. There was enough by then information on the internet that as an amateur to engineering, I felt I could make one of these things. You know, I didn't have to absolutely understand what was kind of in this board, as long as I knew how to put it on that board. And that's what I did. And having got the whole thing going, I sort of thought, oh, this is my new business. And then I thought, no, I'm just going to put it out there as this open source project. And then no other business could ever actually kind of flatten it. And obviously, it's been the best calling card I ever did. I did it rather naively, and it's been just brilliant. So that kind of linked me in with this company called Wasp that are out in Italy. Massimo, who's the lead sort of character to that, he has this desire to build relief housing with a big Delta 3D printer. And what's wonderful is, you know, that huge grade 3D printer that's 8-meter high rig runs off the same Marlin software as that little printer that, you know, I had in the slide before. I think it's probably self-evident what's going on there. But what is interesting here is that they are more engineers and not materially people. They've managed to build the big printer, But in actual fact, it's the material that has given them problem. That even working in Italian summer, that the bulk of the material dries too slowly to be able to actually start building up. In which case, you're almost back to a modular system of a brick rather than printing. So, really interesting. It throws up all sorts of problems. Technical problems of material as much as actually getting the printers going. This was a project with Unfold, the design group again, and that was so often machines are considered to be for mass production and for kind of just taking the human element out of it. And they said, surely at this scale, we can start getting back to individuality. And for this project, they did the design work, but then they asked, is the date on there? No, but this was some time ago. Those people who were 3D printing at the time to print their shapes, but with the character of the individual studio that was printing it, using different clays, different firing temperatures, and then showing it together. Transfer of material, once you can kind of get the kit going. This was interesting. I was invited by a materials library to run this course at a university in Germany. Top left was wax that really was problematic. So we were pushing this through, the little Delta printer. Top right was a wood pulp that it was a master's student who, she wouldn't tell us what her pulp was because that was her thesis, but she was going to publish it before long. We surmise it was probably just PVA in it, but it's literally sort of sawdust and PVA pushed down with compressed air through the syringe system. Cookie dough here, and on the right, silicon as in for sealing your bath. Once that goes off, it makes a really nice material. And if you can get invited to build a chocolate printer for a museum in Zurich and work with a chocolate company, you don't say no. So that's what that was like. This is a course running that I did in Denmark. So for a week, we worked with 3D students and with sound artist students, paired them up as groups, and then the objective was to go from sound to 3D as many times as you could during the week. That was a really nice project, but really hard work. And within this was a couple of years ago as well, the problem was actually having the computer programs, the tool bases to actually work with more comfortably. This is a scientist up in Norwich, near where I live, who I got to know. So Enrico Cohen with the hat on bottom right. He's a evolutionary botanist. And a lot of, this is more Victorian evolutionary morphology, was the feeling was, so this guy, D'Arcy Thompson, was Victorian, like working on sort of Photoshop as to how shapes might have morphed into each other. And so Enrico had this theory that it was much more about direction, and he got a computer programmer to then build a program that would grow from the single cell up with his theories built into how the cells divide. And what's really interesting is, I heard about this on the radio, that he then creates these forms from a single cell. And I said, well, as a creative sculptor artist, can I come and use your software? So we've been playing since then. The image bottom right, he would then actually bring his scientist to my studio to actually experience working with physical material. It's with the scientists I've actually had some of the best conversations about the way material and process affects the final outcome. He's really interested in how color forms on plants, stuff like that. And so he is wanting to say, okay, when you are pinch building a pot, how does the color change from when you are working on a pottery wheel? The different processes and how the color goes through that. So there, really what I'm saying is what's interesting using computation is that it becomes a common sort of technique language that you can collaborate with other art forms so much easier, or with the sciences so much easier. This is back into art forms that in the blue shirt, Charlie Stern managed to raise funds out in Sweden for Unfold, Dries Sinclair and myself, to spend a period at Konstfack in Sweden researching the use of digital techniques with clay and glass. And then we had a period at a glass factory where we did a short batch production of pieces. So that was the outcome. So it's 3D printed ceramic, unglazed ceramic that the glass blows to then blow into. And teaching at Limoges, doing courses at Limoges. Part of that, we go off to a glass factory, and so this has enabled me to continue what was most interesting to me, and that was to be able to 3D print waste ceramic molds that the glass blower blows into. And I could then combine the two materials, so you had the glass material and the ceramic material, and in this case, using bullion, you could play with that duality of negative or positive, translucency, opaqueness, as well as negative, positive, and form. And in these pieces, I'm then putting the ceramic inside. So, how I sort of spoke earlier about the language of ceramics, I'm interested, I'm deconstructing that a bit. The idea of glaze and body is still coming out here, but now I've got a bit of space between them, so I'm using the light to actually decorate or texture the surface of the piece. So, when I refer to myself as a traditionalist, that's a traditional ceramic form using glaze, clay, and strong form, I hope, and consideration of the surface. So thank you very much.